Now that we have seen the algorithm and pseudocode behind merging two sorted arrays, so that in the end, whatever the resulting array will also remain sorted. Now let's go ahead and let's write the programmatic implementation for the same using JavaScript. For that, I'm right inside the project that we have created. Inside the sorting folder, I'm going to create a new file by the name merge two sorted arrays dot js. Okay, let's just minimize the site navigation and let's start writing class merge to sorted arrays. Now inside this class, let's define a function merge to sorted arrays, and it will take two arrays a1 and a2. Okay, as part of the pseudocode, if you see whatever the logic that I have written, I have almost written the programmatic implementation itself. First, in the beginning, we will try to read the lengths of A1 and A2 so that we can reuse them later on in the approach. Let's say const length of A1 equal to A1 dot length. Okay, similarly, let's try reading the length of A2, which is nothing but A2 dot length. Similarly, what we did, to hold the current indexes that are being processed in array1 and array2, we defined a couple of utility variables, which is nothing but I let j equal to 0. In the end, we will have to merge all these values into a resulting array, right? So we will have to create a resulting array, that is nothing but let result array equal to new array of, what will be the size of the resulting array, which is nothing but length of a1 plus length of a2. Okay, and I want to fill all the values with 0 in the beginning. Okay, so that in the later on we will go ahead and we will update those values with the appropriate values from either array1 and array2 in the business logic that we are going to write. At the same time, to hold the current index that is being processed, what we will do, we will simply take current index equal to 0. We will define a variable for that. Later on, we will simply increment this current index by 1 so that we will move on to the next indexes in the resulting array that actually needs to be processed. So now what we will do, as long as the value of I is less than length of a1 and the value of j is less than length of a2, that means we have values that need to be processed in a1 as well as a2. So what we will do, we will simply be comparing both the values at ith index from array1 and the value at jth index from the array2. If the value at jth index is smaller, then we will pick that value into resulting array. So as part of the comparison operation, what we will do, we will compare a1 of I, it is greater than a2 of j. That means whatever the value we have at the jth index of a2 is smaller. So we will have to pick that one. See, I'm only checking it is greater. If it is less than or equal to, then the value will come from array1 only, because in the case of equals, if the both arrays have the same values, it really doesn't matter whether we are going to pick it from a1 or a2, but in our implementation I'm going to pick it from the array 1. So what we will do, we will simply be taking a2 of result array of current index. We need to fill it from the a2 of jth index. Okay, please make sure you are taking extra care when you are using these indexes. If you simply go and jumble the ith index and jth index, right, you will simply be implementing the algorithm in a wrong way. So make sure that I is for array 1 and j is for array 2 here. So obviously we have picked the value from a2 and we put it into the resulting array, right? So in the next iterations, we will have to compare the next index of a2, which is nothing but j plus 1. So I'm updating j to j plus 1, and we will have to update the current index also to current index plus 1, so that in the next comparison operations, next index of the array will get filled with appropriate value. If this is not the case, we will take the value from a1, result of current index equal to a1 of I, and we have successfully picked the value from ith index of a1 and we've put it into the result array. We should move on to the next element of a1, which is nothing but which can be done by incrementing the I by I plus 1, and we will also increment current to current index plus 1, so that in the next comparison operations, next index of the resulting array will get filled with the suitable value from either a1 or a2. Okay, this while loop we are running the logic as long as I is less than a1 and j is less than a2. So this while loop will only run as long as there are values in both a1 and a2 that needs to be compared. But what if the length of a1 is greater than the length of a2? Then we would still have some values left in the array 1. So to process those unprocessed values, we will be writing a separate logic. While I is less than length of a1, what we will do, we will simply be taking all the values from a1 and we will put all the values into the resulting array. So how will we do that? Result of current index equal to a1 of I. So to move on to the next index, we will simply increment it by 1. Current index also we will increment by 1. Okay, we have handled a case where the first array has more length than the second array. But what if the length of the second array itself is more than length of a1? That means we will still have some unprocessed values in a2. So to support that case also, we will need to add while j is less than length of a2, and that is the case, then we will simply pick the values from a2, we will put it into the resulting array. That is nothing but result array of current index equal to a2 of j, and we'll simply do j equal to j plus 1, current index equal to current index plus 1. Okay, now we have handled all the cases. Simply we will return result array which is in the variable result in the end. Okay, this is how we actually perform merging of two sorted arrays. Now let's go and create an object for this and let's try calling it. Let merging of two arrays equal to new merge two sorted arrays. From this MTA object, let's call this merge two sorted arrays function, and let's pass the arrays that we want to sort is, let's say, -10, -5, 1, 4, 8, 10. Similarly, let's try to pass some other values in a2. Let's say -2, 1, 4. Okay, whatever the resulting array it is passing, let's try to merge array in a variable. Okay, now let's simply print console.log of merge array. Now let's try running it and validating the results. See, this file is inside this merge two sorted arrays inside the folder sorting. So we will simply be doing node sorting merge two sorted arrays. Okay, if you see the resulting array, we have -10, -5, -2, 1, 1, 4, 4, 8 and 10. Okay, if you observe here, -10, -5, -2, okay, 1, 1, 4, 4, 8 and 10. Okay, even if one of the array has 0 values also, even if the one of the array is empty array, even if you try to execute the logic, the same will happen, which is nothing, in which we will simply merge the two sorted arrays. Technically one of the array is empty, that's all this is. Okay, before we close this video, let me give even though this is a utility function of merge sorting algorithm, this itself is a very important algorithm that you should always remember, because when you try to learn about single linked list and doubly linked list, there is a problem of merging two sorted lists into a single list. So as part of that implementation also, we will be using the same algorithm. So it is very important that you pay attention and you understand this algorithm very clearly. Okay, so that's all for this merging of two sorted arrays, and I will see you in the next one.